Welcome to the fifth session of Alumni Talks. As I was mentioning, these Alumni Talks brings the experience of our alumni members in front of the new generation for their benefit. So we'll be conducting this talk. We have scheduled this talk second Saturday of every month. So various topics, various experience brought to you by our alumni members for your benefit. Spread the word across. Let more and more members benefit from this. Today's session is the fifth one in the series. Today's session is hosted by Sangeeth Nambiar. Sangeeth Nambiar currently heads the Corporate Research and Technology Center and the Center for Artificial Intelligence at Bosch in India. The research center focuses on research and advanced applications in the field of natural language processing, computer vision, machine learning, numerical methods, and real-time systems. The Bosch Center for Artificial Intelligence mission is to expand the frontiers of AI and, at the same time, apply latest results in various business domains of Bosch. Sangeeth has more than 20 years of industrial experience in various domains, including avionics and automotive. He completed his master's in business administration from the Indian Institute of Management, Kozhikode, and is currently pursuing his Master of Science in Analytics and AI at Georgia Institute of Technology, Atlanta, US. In this talk,
friends, seniors, younger colleagues, or students that we worked with, studied with, enjoyed with, and also many things both while at GCEAAK and beyond. It's really a pleasure. Thanks for the platform. And thanks, Sunil, for also giving the overview of my talk. I would really love and prefer if we could keep this as a dialogue where I'm sure I'm not the only one who knows some things. There are many who might know even more than what I might know. So it would be great if you would also share your perspectives, your thoughts, your input, so that we could keep this as a dialogue and an information sharing session, then a one-way dialogue, which would be great. And maybe I can hold the storyline for the whole group, but then it would be great if each one of you would also contribute what you know, ask questions, keep it alive. That would be great. Maybe I would like to start with a short video, which maybe you have. One second, it said it cannot share my screen. Yeah, I hope you can see my screen now. It should be a tab. This is a video that BBC published in 2018, and the video I think is self-explanatory. We'll just
thinking about my full-time employees and their ability to survive on $8 an hour in New York City. And foremost in all of our minds has been the loss and the grief felt by the people of Orlando. Most of us don't get our health care through the marketplace. We get it through our job or through Medicare or Medicare. And what you should know is that thanks to the Affordable Care Act, your coverage is better today than it was before. Women can get free checkups, and you can't get charged more just for being a woman. To give his employees come together to pass a common, there's a bill that would boost America in very hard times.
Some progress, at least within the small confines of the legal community. I think it's real important.
Here we go. President Barack Obama. When you giving a speech, make sure you use a lot of pauses.
America's businesses have created 14.5 million new jobs over 75 straight months.
We're developing technology. Every technology can be used in some negative way, and so we all should work towards making sure that it's not going to happen. And even one of the interesting directions is that once you know how to create something, you know how to reverse engineer it. And so you can, and so one could create methods for identifying edited videos versus real videos.
Yeah, that was a short video. I hope you were able to see and also hear. Is that the right assumption I could make? Yeah? That's
yes.
Fine? Okay, great, thanks.
Yes.
Great. Yeah, so this I think is well known by now, and also Sunil also in that introductory part said I think fake videos as a thing, right? But I think, and here one important question is how are these things working, right? And how are people doing this? And this is where maybe another latest, which I'm sure you have heard about or even tried or played with, would be ChatGPT. Is that something that at least most of you have heard? Can I have a show of hands, or at least some voices saying yes or no? Are there colleagues or friends here who said yes? Okay, great. There are show of hands raised, right? Good. So just to for those friends who have not seen or worked with or tried it, for example, this is a chatbot, if I may use that word, where you could have natural language conversation with the computer. That's what I'm doing, right? And let me just start any random question. For example, can you please prepare a presentation on generative AI for my alma mater? Yeah. Let's see what it says. There you go. Right? Beautiful. So look at what's going on here, right? So it said, hey, it is having a conversation with me, saying, yes, I will prepare for your alma. It knows what's the context. It is even chosen a title and even structured the presentation and given me a clear outline how I may go about saying and what I may go about saying, right? And one has to remember that what's behind this chatbot is nothing but a single computer. It's not a human being. Yeah? And it's using the data that it had access to in the whole of internet to provide me these answers, which is looking very good, if I may say. Yeah? And what is that? I could also refine the answers to say, hey, can you please include something? I don't know what latest developments. Yeah? Let me see what it does, right? So you would see that it's able to iteratively improve the result or the feedback or the answers to generate some more content. I don't know if that, oh yeah, by the way, it did it, right? I said, can you improve the latest developments? Yeah, here you go. So it had added some slides and said, hey, this is what I could add, right? Now the key question is, how does this all work, and what does it mean? Any thoughts, any people who have tried this, any feedback that you would like to share? And these are the videos which I showed. So the key question I'm sure that's running through many of your minds would be, how is all this possible? What's going on, right? And what I want to say is the nuts and bolts of this technology is something, if I may use the word, it's not that complex, and that's a real reality. Yeah? And if I may also say that this is something that we even learned in high school. I'm sure many of you might say, oh, wow, that sounds interesting, right? And that's actually the reality. The nuts and bolts of this technology that we're talking about is something that we have dealt with in schools already years back or decades back. Yeah? And let's try to understand how these technologies are working with a very, very simple example. And as I said, I would keep this presentation. This presentation is not about a detailed technical introduction or a tutorial. That's not the intent. It's more to excite you. It's more to give you a small storyline so that you can go back and search and find out more. No, that's the intent with which I'm going ahead. Please stop me wherever you want, discuss, share. That would be great. So what's going on there is, for example, when I'm trying to type, say, for example, when I say T, just a random word, not that I intend to be so. What the algorithms are trying to do is to predict the next character first, and then you could call something like the next word or the token. Yeah. So when I say T, when I say then the H, if one of you were that computer, what would you say? What would be the next character? Any guesses? It would be nice if you would also say something.
E. It might be
Can you
E.
repeat, Ramesh? I didn't hear you.
It might be E.
Yeah, it could be the exactly PHP, right? Or something like this, right? And once I
Yes.
find this, the next challenge is about what could be the next word in that text, right? And that's exactly what ChatGPT, for example, is doing. And let me just show you or run through a very simple approach how you could do such things. And please here there is a star and a small disclaimer below, and actually the disclaimer is a very big disclaimer saying whatever I'm going to present is not exactly the method, but this is more to convey or transport the idea to say that how could one even imagine building such a technology. That's the intent of this slide. So let's assume that you are given 5 sentences. That's it. That's the word knowledge that you have. No? Let's assume that the whole of internet contained only these 5 sentences. This is a cat, a dog, this was a puppy, this was a cat, this is a lion, right? And one could argue, say, there are also this notion of positions, so to say, right? I mean, this could be the first word, and of course, computer scientists, as you know, love to start with a zero. So the first is a zero, and then that's a classical debate and dialogue, right? So let's assume that there are also this notion of positions, yeah? I mean, there is a zeroth word, first word, second and third, etc., etc., right? Now the question is, given some prompt or a trigger, can you build a computer that can predict the next word? Any colleagues or friends here who would say, yes, we could do that? And any thoughts how we could do that? No? Okay, then let's go next step.
Taking the
Yeah, please.
previous data, like most probably, which was the most common.
Exactly. I think that's exactly the keyword. Exactly. I was looking for the keyword probable, right? So this is basic statistics, actually, right? You can say, if this were to be my so-called corpus, most probably the sentence that I have to generate have to come with this. Maybe the world in this, the world that I'm talking about, everybody uses. If there was a computer behind and the computer was asked to predict the first word, what do you think it would predict? Any thoughts?
This.
Yes, exactly. Thanks, Roshi. Nice to see you also here. Exactly. Why? Because you say, okay, the first position, I take this. Of course, now I'm also combining the global probabilities of the whole corpus with probability at a position. So in this world that we are part of, every time a sentence is starting from this. So there is no marks to Roshin. Yeah? It always should start with a this. That's clear, right? And then you move on, right? You go to the next step. What do you think the computer will predict, right? You can say, I compute the probability, and the most likely word here is, right? Am I making sense? Are you okay? Please let me know if you are following me.
Yes, yes.
Perfect. And then once I do this, what do you think the computer should do next? And I've done the math for you. Oh, looks like I didn't update this, yeah? This is position 2. What do you think it would be? The probability here has to be 5 out of 5, right? I mean, there has to be 100% probability that position 5 should contain this, right? Is that right? Am I making sense? So this is A, right? It will come. And what about the next step?
Sangeeth, actually, it should be should be 100%, right? Not cat.
Oh yeah, sorry, I did that mistake. Yes. I meant yeah, you're right. Perfectly right. Exactly. So that was a mistake when I prepared the slides. Yeah, exactly. You're right. Good. I'm really happy that you're following me. Exactly. So right, and then last one, right? The position 3. If I were to compute the probability, I would say, which one would you go for? This is a
Cat.
exactly. Wow, that's exactly what ChatGPT or most of the models, maybe a little bit more complex, but this is exactly what's going on behind. So what it's doing is it's computing some notion of probability and probabilistically, or using the notion of probability, generating the next token for you. And that's all what it is doing. You might find it difficult to believe that's exactly what's going on. Yeah. And by doing that, it is able to generate this magically super looking text for you. Yeah. And that's exactly what ChatGPT is doing in its true sense. Yeah. And I hope that's clear for you, right?
Yeah, actually, I have a doubt. Suppose it don't have any previous data,
Yeah.
then how you will calculate the probability?
Wonderful. It's not possible because here
Yeah.
we are talking about a class of algorithms, and this is what we will soon come to, called as supervised machine learning algorithms, wherein these algorithms have to be so-called trained with the data from which it extracts some parameters. That's important. The other class of machine learning is what is called as unsupervised learning, and it may not be able to do such things here. Yeah?
Okay.
You need some data, and that's exactly where the crux of the whole point is. And if you look at what do you think a limitation of such a technology would be? Can you imagine some limitations of such a technology?
Yeah, at the first, it may give you a very wrong answer.
Exactly. What else?
Uh, No, further I don't know.
It can't think anything in a out of conventional way.
Exactly. So that means anything that is out of the data corpus that you have provided, it won't be able to even understand or think or even imagine. There is no imagination for computers. Let's be very clear, right? You won't be able to generate a prediction out of the scope. Is impossible for this, right? And exactly what you said, and that's a very important thing. These things can be factually wrong, and that's exactly the one of the issues of these technologies we are talking about. And there are people who severely believe that, oh, this is right and this is imagining. No, it's not. Yeah. But the power comes from having to have the whole internet as your corpus. So instead of this 5 sentences, if I could train my network, or forget about network, the algorithm, and compute statistics from the whole internet, and that's what the internet provides you access to, right? I mean, you have the whole of data, everything that people have written about the world, about themselves, about content, literature, creativity, everything is parsed or analyzed to build these models behind. And that's the beauty, and that's what is leading to the capability of these models. And we will soon learn what it is. Yeah. Thanks. I really appreciate you guys' inputs, and that makes it a lot easier for me. And what you want to do, the notion of this text is nothing but what people in this field call as corpus. And this is kind of a learning, and I would even put the learning with a question mark. You know, it's not really learning, you're just computing some statistics, but learning would mean something iteratively and optimizing, etc. But kind of to understand the notion. Yeah? And then what you've done is predicting, you know, or inferring something that the user has asked. And here the task that the user gave was, given a prompt, can you generate a sentence for me? And this could have been the same question that I asked if you were to have the corpus. Yeah? I hope that's it. And now exactly coming to a question, some questions about, let's understand some basic terms just in case these happen to be new for you. Know? What is AI, ML, deep learning? So this is about artificial intelligence. ML stands for machine learning and DL stands for deep learning. Let's have a quick understanding of what do they mean. Yeah? Actually, these are all related. Artificial intelligence stands for, you know, building computer systems that can perform tasks which are normally require human intelligence. This could be a doctor trying to prescribe a medicine. You know, this could be a computer system that is able to read handwritings, for example. Yeah. Some things like that, which typically is very complex. And as you know, most of us would have done at least Fortran programming during our engineering sessions. And you know, you would have written an if-else clause, do that. And these things like handwriting, character recognition, it's very difficult to program that way, right? And that's where the beauty of this class of systems, or it's actually a discipline, you know, of computer science, which are dealing with computer systems that are able to do complex stuff. Now, machine learning is a subset of AI, or a smaller part of AI, in which what you do is you're building algorithms mainly, or computers that are able to learn without having to explicitly being programmed. And what I mean by that is, let's go back to that Fortran or C program that we would have written in our engineering classes, right? We would have said, hey, imagine you had to do this for recognizing hand characters. You say, yeah, this pixel is black, and the next pixel onto the right has to be black or gray. And imagine you have to describe a letter to a computer using your own if, else, for loop, whatever constructs you have in the programming language. It would have been amazingly impossible, I would say. At least I cannot imagine how I could do that. Yeah. And what machine learning tries to do is, don't do this, don't program the computer explicitly, but instead give it a bunch of data. And that's what we did in our previous example, right? We never told the computer that this is how sentences are made in the world, right? What did we do? We gave it 5 sentences and asked the computer to learn from those sentences, and then use that learning to predict or do a task, right? That's what machine learning is all about. And deep learning is a class of machine learning algorithms which tend to work beautifully well on complex patterns. Why? And one of the things that they use is they use what is called as artificial neural networks. Yeah, and one thing that I will say is while these are inspired from human brain and neural networks which are found in human bodies, it doesn't have anything more to do with than human brain, just to let you know. These are just some mathematical functions which are inspired. That might be the right place to stop. And deep learning uses these kind of models to do the task of machine learning. That's what it is. Are you with me? I know this is a little bit of theory, and this is the last theoretical slide. The rest is all going to be pretty simple and straightforward. Yeah. Great, thanks. And now let's come to the same question that you asked. I couldn't find the name of who asked the question, but supervised learning. You know, in most of the problems that we are now talking about, we are talking about supervised learning, where the notion is you have a data and you train an algorithm, and with that algorithm you are going to do a task, and that's what we are going to do here. Yeah? And here I want to check with you, how many of you know what supervised learning is. Any thoughts? Great, Rahul. Good. And let me again tell you, you have learned the nuts and bolts of doing that already in school. Yeah. And let me start with an example. Let's assume that you're given a data set, and by now I think all of you would say, to do anything in machine learning or with supervised learning, you need data set, right? Here is your data set. There are images of dogs and cats, right? So here you see I have labeled, so hey, this is an image of a dog, and cat. And now given a new image, I want the algorithm to predict or classify, and that's the word term that the practitioners use, to say, is this a dog or a cat? That's my problem. Yeah? Very simple and straightforward. Let's try to see how can we do this. And again, I would say, yeah, the how is the question, right? And we all are engineers, and the moment we see something, the question is how is it working on, right? And again, the same thing, the nuts and bolts, we have all learned it at school, great. Yeah? So we can be rest assured. And let's understand. And one problem that most of us would have answered in our exams and learned 10, 30, 40 times is given some criteria to say maybe if I were to sell a chair, I get 10 rupees as a profit. And if I were to sell a table, I get 20 rupees as a profit. How many chairs and tables can I keep in my shop if I have 1,000 rupees to invest, right? So provided by I need to maximize my profits. How many of you remember such problems at school? Any raise of hands? Great, at least some. Nice. So this is one of the cornerstones on to make this happen. We used to call this optimization, right? You might know this. And this is exactly what we use, but maybe a little bit more complex with much more fancy compute-intensive algorithms or whatever. Another problem that we used to work is to say that given a table of dependent and independent variables, example, suppose you were to be given a table with the area or size of a house, for example, and you can compute the price of it. Can you, given a new area of a price, can you compute how much this house might fetch? Let's assume that the price is a direct function of the area of the house, right? Does anybody remember these kind of problems? Yes or no? And what would we call such problems? Any hints, please? I need help. Linear regression, right? Of course, linear is one word, but regression could be the class of problem wherein you say, oh, I have some data points. This is where, I have independent variable, which is the size of the house. And then my dependent variable is the price that the house might fetch. And I try to learn a linear function, which kind of represents the data that I have. And I could extrapolate, interpolate whatever circles I want. And then given a value of the independent variable, this could be the area of the house, can I predict what could be the dependent variable, which could be the price? Is that okay? Are you guys with me? Do you remember such problems dealing with? You could have applied it for multiple other problems. Yeah? Great, thank you. Thanks. Great. Yeah, this is what I said, right? I mean, we say y equal to ax plus b, that was the assumption, and we compute the best values. And what does best mean? The value such that when I place this line through the data points, it has to provide the least error, right, or difference to my data points. Of course, meeting all the data points, if I were to draw a line which goes through every data point, it's close to impossible. Neither do we want, because there will be errors. But and this is where we employed what we did earlier. We called it optimization to come to the values of this a and b in a way, right? And then we would compute the value of a and b and use that value of a and b to say, given a value of x, that is the size of the house, can I compute the price, which is by ax plus b, right? This is what we did. And this is exactly the cornerstone of what we're talking about. And we'll see how. And the only difference is, instead of a and b as two parameters, in my model, I'm going to have maybe tens and hundreds and thousands and billions and sometimes trillions of parameters. Let's assume that we are going to build an equation, but it's not really an equation because there are non-linearity. And here we have assumed a very linear relationship where we can do it using a multiplication and a plus, but that's not the case with most of these deep learning networks. There are non-linearities which are embedded, and then you learn these parameters, and that's what exactly is going on. And now I would ask the question, can we do the reverse? Meaning to say, suppose you have built this regression model. If I were to give you the price of a house, do you think you can estimate the approximate size of that house? Would that be possible? Anybody, please?
Yeah, it could be.
Yeah, you could flip that equation, right? Instead of computing y, given y, you could compute x, right? That's pretty straightforward. And that is what generative AI tries to do. Yeah. So with this, more or less, my presentation is over. Rest is all putting some more meat into this board. And that's what generative AI is about. Yeah. And let me explain. Now, coming back to a classification problem where we had this data set of cats and dogs, I said our problem was to say, can you build this is called as a binary classification problem. Can you build a model which can predict the y0? There is no reason there. It could be the other way as well or something else. That's okay. Which can output 0 if it is a cat picture and 1 if it is a dog picture. That's all what it has. And then you optimize the parameters of this model. And I told you that this is a model with n number of parameters and typically running to thousands and billions or millions at least. And you optimize it, and that's what you do. And this is the process called as training. And once you train the model, you use the trained model, you pass the input to that model, and the model spits out cat or dog, hopefully. And you could also make some mistakes. No, that's the important part that's there. And this we call training. This we call inference. This is what machine learning is in short. Now, how many parameters, right? And GPT-3, and that's what we use using ChatGPT on the web, has 100. And please note in here, the y-axis is not in normal scale, it's in log scale because it's too big, right? BERT, which was a model for NLP that was published long back, that had around 345 million parameters. That means some more zeros, you know how much. And this GPT-3, and that's what is powering the ChatGPT that I just used on the web, that has around 175 billion parameters. And GPT-4, which is already there and available for premium users, is supposed to. I don't think they have made it formally published that numbers. I could be wrong here, but at least rumors are that it has around 1.7 trillion parameters in that equation. Okay? Now you assume that you need to optimize, right? And now coming back to a question, do I need data? Now imagine that you have to build a model with 1.7 trillion parameters, right? Then you can imagine that you need huge data sets which at least cross this, because you have to estimate the values for these 1.7 trillion parameters, and that's the challenge in training. Yeah? And now, is that clear? Is that the whole field clear, and what happens at least at a very top level clear to all of you? Great, thanks. Yeah, so then let's step into generative AI, and that's what we wanted to mainly focus or talk about in this session. And as you have seen, we talked about the house example, where we say, given the price of a house, could you estimate the area of the house, right? And that's exactly the notion here. It's of what you want to do. And the idea is that suppose you have a generative AI model. If I were to give a trigger or an input vector to it, can it generate data that I originally want? And here the data is something that could be an image, that could be a sound, or for example, an audio file. Or this could be a text, etc., etc. And this is what we call today as generative AI model. And there are many which are out there. But important is that once you do this, it can also be something else. You know, there is no guarantee that I can say I will get a cat like exactly like this. That's impossible, more or less. And that's the important part. And again, an engineer's question: how does this all work, right? And what's behind and what's powering this, right? And that's an important thing. And one of the technologies, and don't worry too much, and this is what people call as GANs, or generative adversarial networks. And that, so instead of training a single model which can walk you from X to Y or input to output, what you do here is you train two models together, more or less. That's kind of a very crude way to tell you. On one side, I have a bunch of training sets. That means these are real images of cats in this example. And I have a generator which is trying to generate images, some random image, you know, from how and where, and that's exactly where a lot of work is currently going on. And then I build a discriminator. So you already saw that we built a discriminator, or I will classify, I would say this is a cat or a dog, right? Very similarly, I build a discriminator which says is this a real or a fake? And then I train not music for somebody else. It's generating some so-called poetry. It's generating content, text. You saw that, you know, I was asking ChatGPT, how can I create a content for my presentation? It was generating that content. It is able to summarize. Drug discovery, and this, for example, in general has been one area where AI was really used, because And here the important problem is that in problems like drug discovery or design optimization in general, right? The problem is when you're designing something, this could be a drug, this could be an engineering design, your design space is too broad, and you do something like DOEs, design of experiments, to come to certain combinations of things that you want to design and then test it and validate it, right? How fast can you get to that possible molecule in a drug or a healthcare scenario, right? And by suggesting those possibilities and prioritizing them, magically this database methods seems to be making the whole process efficient. That's very interesting. Design and clothing, for example, you saw the images that Midjourney created, right? Maybe some of them could translate to real clothes that you could buy. Content generation in games, because in games one important problem is how do you generate new scenarios, situations that one could have gone in, right? And for example, and then the key question there is, oh, wonderful, right? Everything is great. It looks very interesting. Is it time to relax? Can we just use? And that's where exactly I think when I showed the text example, you guys also shared some of the challenges that you envision with such kind of a technology. And that's exactly where GenAI is today struggling with. One, and the real answer on the in the field is that unfortunately no. There is a lot to be done, and there is a lot of concerning things to handle as well. That's very important to keep in mind. And one notable figure, Jan LeCun, who is also a very important figure and kind of one of the godfathers of AI, if you may go. He says, if you look at autoregressive LLMs, and that's what powering ChatGPT, for example, they're very good at writing assistants. It could write things for you. And very interestingly, ChatGPT could also write software code for you. And I even tried it myself. It's working to some extent. It's able to generate drafts for you. It's able to polish what you have written. It could formalize it better. But important is to remember that it's not good at. And like you said, if you understood how the technology works, you can logically conclude that it will never be good at producing factual and consistent answers, right? Meaning every time I ask ChatGPT, for example, the same question, there's a high probability that the next time I ask that question, it could generate something else for me, because things are changing. And the facts for this kind of methods are just coming from the data. And if the data is corrupted, you have wrong facts because it has no causality inbuilt into it. It doesn't know the physics of things. It doesn't know the real world behind, right? So naturally, incorporating latest information is a challenge. Behaving properly, there is no notion of the right thing and the wrong thing. Reasoning, planning, math, etc. Still, these things are not good at. While people can try, you can get answers, but that's an important thing to really keep in mind. Yeah? And then, yeah, he quotes in one of his recent talks saying, hey, we can easily get fooled by their fluency, but they don't know how the world works. And that's really the cases. Now, when we look at ChatGPT and what it has written, yeah, English is perfect, but many things that is written may or may not be correct. And that's exactly one of the big challenges there. Yeah? And any questions, comments that you would like to add here?
Yeah, just one question. So you told like there is a discriminator, okay, which tells you whether it is a true or fake one. So do you use another algorithm for that compared to the generation?
That's exactly where people are trying different approaches. You could use, again, if you ask a deep learning practitioner, what he does is he slaps a deep learning network, which is nothing but an artificial neural network, to every block of it and say, you train on this task, you train on this task, and magically it's working. And that's where there are different architectural structures people have proposed in research and science, for example, the Siamese networks, etc., which tend to have different properties and different advantages and limitations here and there.
Oh, okay.
And
So,
one of the big, yeah, please.
yes, Sangeeth, just one question. So basically, as you mentioned, all this research and development is being done independently by different organizations and consortium. So there is no standardization on this part.
Not yet. This is exactly one of the big jobs to do. Yeah. Of course, maybe standardization is a very strong word to use. One of the ways that, in research and science, as you know, you publish in the tier 1 forums so that people can get used to it and etc. And that's the thing. There is no standard set, and that's exactly where you're going to. Exactly, you also see that there is a need to standardize things.
Yeah, yeah, yeah.
Yes, right. And one of the biggest problems these technologies today have today is the problem of what is called as hallucination. Yeah? For example, this is one method is an image vector. I hope there was a short brief interruption. I'm sorry for that. So here you pass an input vector and ask it to generate an image. And here you see an image that is generated by an algorithm, and you ask the question, how do I train, right? How do I, can I use the same network, for example? So here what they've done is they've used a network that was trained to detect dogs, and you see what that network generated, right? You can even, there is a notion of dog there is hallucination, there are things that never exist or would never exist. And here there are some networks which have generated images of scenes in real life. And here you see some people which are without legs, for example, right? It's hallucinating. And you can imagine why. It's very, very trivial, right? You say, hey, I've seen this 10 times, but it never understood that there is a relationship between a leg and a torso of a person, right? It has seen this, and whatever it's seen, it tries to put it into a picture and give you as a set of pixel values, right? That's exactly what's going on in most of these things. And many other issues stands. Biases is another big issue that people are talking about. Say, for example, if your data set always contained a certain pattern, the algorithm is going to exactly do that. And one classical issue, not about generative AI, that people have talked about in the US is you had algorithms which would give loans. So they had algorithms which would check if a person who is applying for a loan is worthy of it, right? Looking at n number of parameters. This could be his income, where he comes from, ethnicity, blah blah blah. And it turned out that these algorithms were always preferring white people to give loans for, right? And this was a very well documented thing. And it's so natural because in the past, if you have learned from the data of giving loans, these are largely in banks, white people giving loans, and they would naturally prefer white people, and we know the situation, right? Such biases, if they existed in the data with which you train those models, would exactly propagate into what it's generating, and that's a big problem. Another big issue is what is called as the echo chamber effect. For example, I'm sure you also know this from social media, be it YouTube, Facebook, LinkedIn, whatever, right? You search or just happen to even watch a video for 2 seconds more than the other one, suddenly these algorithms starts presenting you with the same content or content that is very similar or related to that, right? So what happens is you are entering into an echo chamber where you just looked at something and the whole world is full of that. And you don't have access to anything else. Is that fair or right? Should we standardize it? Should we put a limit to that? That's exactly the question. Yeah. And then the other biggest issue is the resource intensiveness, right? And I talked about ChatGPT and GPT because they are so famous today, right? And we saw that the GPT-4, which is coming up or already been there on the block, has 1.7 trillion parameters. Now, imagine you need to train a model or a network on for such a big model. It's very common sense. We say if you have to optimize n parameters, you need much more data than the number of parameters, right? There are some numbers as well that you would say, but you don't really need 2 times or whatever, but let's assume a safe bet. So you need so much data. And in many of these cases, the kind of ideal size of your data is every data set or every web page or every content that you have on the internet. This is massive. And this means 2 things. One, you need amazing number of compute resources to do this computation of optimization, which is again an iterative job, right? And this also means power, meaning really literally electricity to do this, right? Because these chips often are not very power efficient, and that's another big issue. And just to give you keep things in perspective, the possible numbers, I use the word possible numbers because there isn't any official statement about what it costed or whatever, but at least rumors or some reports, and I assume that there is some rationality behind why this. Even Sam Altman from OpenAI had stated that the money that is spent to develop ChatGPT or train it is around 100 million. That's a lot of money. And it consumed an energy of around 7.5. This is an estimate, please. This is not a formal statement. Around 7.5 megawatt hours And just to keep things in perspective, Idukki Dam in Kerala has a capacity of around 780 megawatts. That means 1% of its power has to be used just to train one machine learning model. 1% of our Idukki Dam. That's a lot. Okay. And that's one of the important issues. And then the other thing is limited applications. Say, for example, as of today, this tend to be able to be applied where you have large data sets. If I need to do a very specific individualized application, it's very hard to get that. Yeah? And then there are also this notion of ethical concern. Is it right? And when I'm doing it in with GCK, the other question, what's it about jobs, right? You saw that 20 to 30% of efficiency can be brought in the workplace. That definitely would mean jobs shifting. And is it different, right? Is it right? Now the algorithms are giving loans instead of human beings, right? The other classical debate has been, let's assume automated driving cars, right? The car is driving, there is an algorithm which is trying to do it, machine learning or otherwise, that's okay. And it sees an obstacle on the street. Let's assume that there are two ways it can drive, left or right. And on one side, there is an elderly woman in front of the street, and on the other side, there is a baby on the street or a kid on the street, right? It's clear that it will hit one of them. You can't prevent that. Let's assume that the car is so fast, it's there, it didn't direct whatever, right? Which way should the car choose? Right? And this is a very, very sensitive question. Human beings would have decided some things, and there are logics either ways, right? And what you should do and whatever. So these are things that are very, very becoming very, very important in these. Yeah? And then this, as you can imagine, with generative AI, is a technology disruption, if I may use that word. And technology disruption is not new to mankind, right? We have seen it. Examples could be the stone tools. This could be the invention of fire. This could be the invention of agriculture, printing press, nanotechnology, steam engines, and many, many more, internet included, right? But the key question is it the same? Is it different? Yeah? Is generative AI also a similar disruptive change in which we as humanity will anyway master and change? Just like that, this will also happen and we'll figure out a way. Is there anything different? Any thoughts? Is there anything different? I would say that this is something that we have not seen ever. Humanity has never seen a technology disruption like this. It's not just that it's new, that's not the only thing. It has some characteristics which we have not dealt with in the past. Any suggestions? What it could be? Yeah, Vinita.
Maybe it is that power has been concentrated in the hands of a few to such an extent that it has become very inaccessible. For example, as like think of fire. Any person, I mean, different populations living in different areas of the world, various time, could have discovered fire.
Right.
They could have started agriculture, but the entry cost of getting into having that much access to data set, investing in this, the entry cost is going up, and the power is getting concentrated.
Yes.
So the social impacts could be, well, it could worsen the inequality.
Exactly, that's a very important point, right? I mean, so if we all agree to train the next large language model, no? That's a name for models like GPT for that matter. Yeah? We need to now contract KSEB to give us 1% of the power that they generate from Idiki. That would be a lot of money, right? And this is one of the biggest fears, meaning to say the divide in the society might even become even bigger, meaning rich and capable companies would become even more powerful than every company being able to do that. And that's a very important problem. There is something more. Can you imagine? Very, very important point. Anything else that you could imagine?
And it's a very disparate to technology. Because I seen last week I had attended one conference, and AI is doing autonomous weapons. It itself guides himself and hitting the person. No one is guided. It guides by itself and it goes and hit. And if that technology goes in the hands of wrong people, gone. Like nukes, nuclear energy, we are using electricity, we are utilizing it, and we are very happy. Today we are talking here and we are seeing from long distance. The same nuclear energy is used for destruction, nothing is remains in the world. Entire country will be destroyed. The same thing with the AI. According to my perspective.
Yes, I would even
what we train the data, how we train the data. That's very much important. If the data has a bias, everything has been biased.
Yes, yes.
And this where nowhere, no in the world, nowhere is coming up to between good AI and bad AI. The difference between the good AI and bad AI. Bad AI. That is the where I'm thinking so.
Perfect. Yeah. So I would even extend what that's exactly the direction. Autonomy. This has some autonomy, but I would say it's a technology that has not only autonomy but also has agency. And I will clarify what I mean. Yeah. Every time we have these disruptions, these are some random examples. Yeah. Here. Of course, fire can be something we say, yeah, the nature can create fire by itself. Every other time, the button to use or not use a technology, including nuclear, just to let you know, was in the hands of a human being. Yeah? If I had a fantastic stone tool, I decided whether I can punch it or use it to cut or whatever, right? Agriculture, I decided when to sow the seeds and when to reap and what to do. I could kill it. Steam engine, I drove the machines. I switched on and switched off the printing press. I decided whom to circulate the content to, right? But imagine AI, it is more software. And with generative AI, now imagine that this is residing everywhere in computers, right? And I'm not painting a world where there is an alien intelligence or something that is really driving. No, it could be our own mistakes. We are still in control, still, I would say. But there could be a possibility that, yeah, havoc was created. And that's why I say this technology has the potential for agency. And one small example that you see is the problem of the echo chamber, which I just now mentioned on social media, right? You just happen to look at something, or maybe you just that video was playing and you were looking away, right? So Facebook or whatever social media thinks you like that, and that's the kind of person you are. You got put into a basket, right? And it starts showing you, and maybe that takes the world in a certain direction that you don't have control anymore, and that's a big worry that people have. AI for social good is a very important topic, and this is a very new disruption that we have not seen, and this is really worrying on one side. Of course, it has its opportunities, and I think we as engineers should always look both sides. We shouldn't be biased one way or the other. And then the other important thing is, while all these risks that you mentioned, all that is valid, the issue of the divide getting created, the rich being more rich, or the powerful getting more powerful, or the bias issues and all of this are happening at the same time, we don't have much clues how this thing is working. And that's the reality. Even if you talk about deep learning, we don't know much how this works. It magically works. That's a reality. Of course, there are attempts and there is much more. It's not at the level what I mentioned. It's not entirely a black box. It's not so. But it's also not at the place where I can write a clear equation and say, this is why it is. You just compute this, you will get the same output. No, that's not where it is. And that's a worry. You might end up blowing things up which you don't know. And that's really a worry in the field. And hence, the important key directions, and you said it all. I don't have to read it, just my job is to summarize, saying, hey, we would continue to see advances in the AI models, and like you said, what is that architecture? Should I use the same model as a discriminator or the other one? How do I combine them? How do I give the feedback? That this would still continue to happen. What is today happening is, how do you combine multiple modalities? This could be text and images together. With Midjourney, you already saw that. There were text and images getting combined, and audio is already happening. More and more efforts to improve the controllability and interpretability of this. We call it explainable AI. This is another very important field. We are trying to understand how is this all working, and how do we ensure that it's working in the right way. And that's an important thing. And exactly as Suren said, how do you ensure that AI does not produce harmful content or harmful effect, if I may also use that word, right? And how can we ensure that human beings are still able to be in control is a very important topic. And this naturally drives us to the last two. Ethical guidelines. What are those ethical guidelines? How should you develop these models? How should you train? For example, this problem that was easily documented, face recognition, right? They tend to be working very well on certain demographic classes, example, white people, right? Whereas not. And this was a natural consequence of the data set not having those classes enough.
or meaning underrepresentation of those classes, for example, right? Or regulatory framework, and that's the world we're talking about. Europe is now well advanced, where they're coming up with an AI law, or most probably it will be sanctioned and put in place. And that's really areas where things are happening, and I think these are also very, very important to make this useful and working for us. Yeah, and that's all what I had. That's my last slide. So yeah, Vinita and all, open to questions and comments. Please, I would also encourage if you would also answer others' comment questions and answers. It's not only me.
I was wondering if I could add one more to the key future
Please.
directions, because we as engineers have a tendency to go for the fanciest model and looking for the appropriate technology. Whether let us say if the solution doesn't need AI, but if it can work with a low cost, low resource intensive, and more importantly, much more explainable, because the more complicated the technology gets, the more the distance between the people who are impacted by the technology, maybe the poor communities or the people who controls the technology, the distance increases. So yeah, maybe appropriate technology.
Right. Yeah, the simpler the better. Yes, you're right. That's definitely one of the rules that one should follow in any engineering discipline and practice. You're right, not just about AI. You're right, fully right. Another often a pitfall that I've seen, exactly as you said. On one side, people say, "Let's put AI into everything." Many times you don't need that. That's really, I see. One of my missions is at Bosch, for example, to scout for opportunities to improve our company and its performance, both in terms of new features or in terms of efficiency improvements of the company by applying data science and AI. And many times people say AI, that will solve. The other thing is many have blind faith in AI. Say, hey, just put AI, it will solve. That's not the reality. It doesn't work. If you Any questions, comments, additions? Yeah, Joshi. Go ahead. Don't worry to be formal to raise the hand and all that. Just go ahead. It's our platform.
Great, Sangeeth. Thank you very much. It was an excellent presentation, even though I started a bit late. I'm actually working in cybersecurity, and my passion is artificial intelligence for cybersecurity. I did attend some courses also for that. I have two questions, if you don't mind. The first one is about the last slide you put up about the key features, directions. How do Indian government going to control, or what are the controls available at the moment to avoid any issues like criminal activities which uses AI? Recently, there was a video. Someone was using the voice and video call and getting some money out of some of his friends, and there will be a lot of activities happening in UK. I'm living in UK. I know the controls which government put up for foreign investment in AI, exporting technology to different countries and all that. What is in an Indian government's general view, or what are the controls available now, please?
Yeah, sure. I don't have the answer. Honestly speaking, if there are other friends who are there in the call who have more insights, please do share. I know that they are debating and discussing this. As you know, it started with all the data protection bill and all that, right? And there was also a white paper on AI that the DATI and the government was also publishing. But we are yet to have a clear guideline and a law and framework. That's what I understand. Yeah, Niti Aayog has already published some materials, and even the government is also planning to put in more money into this field, both to enable and encourage research, but also to support companies who would solve that niche and the digital. Anyway, I was also talking to the guys behind the whole digital infrastructure layer, the India Stack guys, including Pramod Verma, who is one of the key architects who was there. And he said one of the ways Indian government has tried to do is, one, we are going to open source the technology so that the more eyeballs, there's a high probability that someone can fix or find the issues so that it's robust, right? And second, we are going to enable people to build multiple applications on our platform or stack, so that we assume that when there are interactions and one is watching the other, it's not only one central entity watching everybody else, but you're democratizing even the problem to watch and govern the whole system. Right? That's one thought that he had, for example. Just one tip.
Can I ask the second question, please?
Please.
Is that okay? About the skills, especially in India, like how are we going to fulfill the skilling in AI, especially like what is happening at the moment, please? That is particularly a personal interest on me. I would like to know a little bit more about that. Opportunities for youngsters, opportunities for our children, as well as for ourselves.
Sure. Yeah, I think a ton of courses have come up with masters, bachelors in AI, certification courses, etc. That's not a problem. What is also parallelly changing with everything to do with generative AI is, and I was speaking to Professor Seco Polton from CMU in the US, who is also the scientific advisor for AI to our team. He said one of the key jobs that AI is disrupting is the job of the AI practitioner. Say, for example, with this whole thing that has come up called as foundation models, right? Where you have large models which are able to generate content for you. You don't need super expert AI developers or engineers to develop an AI model anymore. Either you would be using an interface from OpenAI or ChatGPT, and that goes exactly in the direction that Vinita said. For example, large companies like Microsoft or OpenAI are becoming more powerful and central to building those applications, and they take large part of your value because you're using their models, and your application is just passing the output and just giving the results out. That's happening, and I think a lot of emphasis on prompt engineering is going on. Companies are trying to upskill people in the area of prompt engineering, using these methods and interfaces which are out there to optimize tools and develop new and quicker solutions, and that's something that is really happening. For example, I think most of the IT services companies now claim I don't know, one is a claim, and I'm sure internally also they are targeting an improvement of 20 to 30% efficiency improvement in their businesses. Yeah, because they assume that applications can be built much faster using these technologies. The Microsoft GitHub Copilot is one example, wherein you have integrated that into IDEs and you can generate code using that, or at least boilerplate code, even if you're not developing the complete application. That leads to a lot of quick results. Right? That's happening. I hope that answers your question.
Yeah, excellent. Thank you very much, Sangeeth. Also, thank you to the College of Engineering team for conducting such excellent seminars. Very useful. Thank you very much, and good luck to all.
Thanks. Anybody else? Any other thoughts, questions?
Sangeeth, one question that I had from my side. First of all, a wonderful presentation, very insightful. I intend to use some of the things that you said to the people I'm working with. It was very simply explained. Thanks for that. What I wanted to ask was, there is some perception that like the Chat GPT and the GenAI tools that came up, right, I think from last October, right? There is some kind of capacity or capability reduced because of the data that they're using is more of copyrighted data and all that. So there is some tweaking and all that they had to do so that it is not a fully capable thing that is actually brought out. Is that something you feel, or is it just a
That's true. I think it's both sides. One, you know that yes, there is a lot that needs to be done, because then the question is for which purpose? No, what's your benchmark to even evaluate these technologies, right? That's also still under question, and I think this goes hand in hand with the whole scientific community not having understood enough about these technologies, right? For example, the copyright is something that we said. I know that there are a couple of lawsuits which are out there, including I think the Harry Potter team, right? Which said, hey, you are generating content, looks like you have parsed this content, right? And then how do you argue? I could imagine, I don't know, a possible argument could be, no, I did not parse your book, but I parsed the content of people talking about your book, right? And how do you even, and that's exactly, there is a lot of open space to even decide what should those legal frameworks be, no? And one, for example, we are evaluating, can we use Copilot, for example, to improving efficiency in software development? And one classic question that we have is, suppose these tools generate some piece of code for me, even it might be a small one. How would I ensure that I'm not infringing on some IP of somebody else, right? That's still open. There are no clear answers, honestly. Yet, no, I think we'll figure that out. And one promise, for example, Google, with its Vertex AI capabilities that they're offering is to say that and another common concern in the industry is, suppose I'm using ChatGPT or these interfaces from OpenAI, example through the Azure Cognitive Services, I have to pass my data to these companies, right? Are you using my data to improve your models? Is that okay? And let's assume this risk, right? I send a prompt. That means I say, hey, generate a content for visualizing this or whatever, right? A code. You use that to train your model, and my competitor uses the same model asking a similar question. It gives a similar output, or even leaks my content into that competitor's generated code, right? All these are still unsolved. And one offer, for example, what are companies like Google with the Vertex.ai, for example, offering? So one, they say, well, I'll take this model, example GPT, I'll host it in your premise, or maybe I still host it in my cloud, but my cloud is not talking to anybody else. So whatever happens there stays in there, right? That's one offer that I have. Second is that I ensure that these models are trained only on copyright okay content, meaning to say it's okay that I'm reading and generating things from that. So these are the discussions ongoing. Is that true? Is that enough? Can you still work? I don't know.
Need to be discussed, right? Yep. Thank you. Thank you. Thank you.
Sangeeth, this is Matthew from 2004 batch.
Hi, Matthew.
Hey, Sangeeth. A nice presentation and nice content. I'm also an early, let's say, participant of AI adoption in wherever place I work. One thing which bothers is a strong word. Maybe one thing which I used to think is about how much governance is in place when somebody think about AI to implement, and how much is expected and how much we can expect from the AI implementation practice, whoever it could be, Google or Microsoft, is in place. Because someone has to decide as to what extent I need to, let's say, implement or let's say even think of AI. So what is the, let's say, governance process in place, or is there a governance in place as a company, as a CTO? What should be his thought process?
Right. So some of sorry, I think my internet broke for a moment. So what I want to say is, I hope I'm back and audible, right?
Yep, you are.
Yeah, so this area of DevOps for machine learning is now called as MLOps, machine learning ops. That's a field which is trying to build tools and methods to the whole problem of development and deployment and operationalization of machine learning tools, methods, models, whatever they are. The whole area of data management is getting a lot of attention and traction over the last years. This has led to what is now today called as data-centric AI, meaning to say where the focus is shifting. Earlier, the more people looked at the algorithm and said preparing the data is a not so good enough job or not the best job to have. Yeah? It's a stupid work that somebody else will do, but then I focus on the model or the algorithm, so-called algorithm side of it. That was called as a model-centric AI. And today, many are arguing that there is not a, of course, development, and I have put it as my first point. I mean, advancement in the AI models is an important area, but that's not the only thing, nor will it bring the biggest gains in the future. That's what people try to argue and say. We need to focus more on the quality of the data. How am I going to manage? How do I compose the right data sets to train, to validate these models? And that has led to this field called as data-centric AI. You could also look into what that is. Yeah, and this is still a fast evolving. There are companies, there are tools, there are methods that are coming out every other day, trying to improve both the efficiency and the accuracies of developing machine learning models for AI in general.
Okay, perfect. So, I mean, that concern should be, let's say, channeled back to the data itself as to how much, how much we can leverage on the data. And is that the point you conveyed, Sangeeth?
Now, what I think is you need to also think about, like we already said, right? We need to think about the data inside. What's going to train these algorithms, on which it is, and how do you manage? How do you curate those data sets? How do you get the right data sets? How do you compose those data sets for training, validation? All that are very, very important problems. That's the message.
Makes sense. Makes sense. Thanks.
Yeah. Yep. Okay, so maybe.
Yeah, just one last question. What do you think? Like, how long it will take to make it a standardized thing, so that yeah, we can use it?
I have no idea. No, I think I once remember discussing with a lawyer, and he made a very important statement to say that laws cannot be in advance, and
Oh,
it was never be in history. Yeah,
yeah.
loss also always comes later. Once things happen in the world, people try to look at, because you cannot make a law for every single situation, right?
Correct.
You need to generalize it. You need to look for the best way. You need to think about fairness, about your values that you want to uphold in your legal system, and all this. So it would only follow. That's always clear. And that means, I think, especially in this field, the developments are pretty fast. You know this.
Okay.
The world changed with the launch of ChatGPT, for example. So I think there will always be a gap between what technology is able to do and what is really regularized in the legal frameworks. I think there will be a gap all the time.
Yeah.
And I
So
think the speed with which AI is developing only makes this gap much more wider.
wider, yes, yeah. Okay. So maybe after its initial disruptions, we may get some.
Hopefully, yeah. Right.
Okay. Yeah. Thank you.
Yeah, welcome. Vinita, I think you had something to share.
You said that the speed with which AI is going, there is always going to be a technology gap, and I agree completely. But maybe we should rethink our strategy from, go fast and break things to go slow and make things. Because I remember reading about, Wipro's, how the family algorithm and what the errors, and not naming, sorry, organization, but how the errors led it to people being out of the Assam citizen registry, actually put in detention center when algorithms don't account for spelling mistakes in area where people lose documents due to floods. People don't have the same spelling for their grandfather because of illiteracy, lack of textual literacy, and all. Because all of these things, when especially when used in for governance and in social situations, have real life implications for people.
Right.
So do you think, maybe, I mean, we all get excited about technology as engineers, maybe time we think, build instead of go fast and break things, go slow.
I don't know. Honestly, I don't know. But if you look at the society, right, it's not only about one person feeling or doing, and it's pretty hard to move a complete society into a direction. History has not shown otherwise yet, but that doesn't mean it cannot happen in the future. Yeah, that's important. Yeah. So there are nothing more. Then I would say a big thank you.
Yeah,
for
if
all of
if there are no more questions, I intervene. As Einstein told, things should be explained as simple as possible, but not simpler. So AI has been explained in a much simpler fashion, and thank you for that, Sangeeth Nambiar. Actually, AI would have been sounding alien to me. I'm someone from civil engineering background, but it was so interesting, and actually I could relate also because my MTech project was, that was decades ago, was on expert systems to identify distress like cracks, etc. in structures and suggest remedial measures. Things have grown much larger than expert systems in as far as AI is concerned, but still, the participation in this particular event actually proves that it is something that is touching upon everybody and everything, and so everybody is interested from all the backgrounds. We had around 70 people at the peak, and we had around 50 people participating all throughout. Alumni Talks is something that CEAAK College of Engineering Alumni Association started a few months back, and this is the 5th session of the Alumni Talk, and it is getting more and more popular. Big thanks to the presenter of the day, Sangeeth Nambiar, for your very interesting and very informative talk. And thanks are also due to DK, who is the coordinator of Alumni Talks of CEAAK. And on behalf of College of Engineering Alumni Association and our college, our alma mater, I thank Sangeeth, DK, all the participants, and the interaction also was very, very nice, and a lot of people participated in the interaction session, and I thank all of you. So officially, big thanks from college and the Alumni Association. Thank you very much.
Thank you all. I do enjoy it.
Thank you.
Thank you.
Bye.
Thank you. Thank you all. Bye. See you on the next one.
Yeah, bye.
Thank you.
Bye.